Assalamualaikum warahmatullahi wabarakatuh and a very good day to everyone. My name is Alya BINTI Izmal and today I will be presenting my paper review for BIIT 2303, which is Network Infrastructure Management. The paper I selected is titled 6G Virtualized Beamforming, a novel framework for optimizing massive MIMO in 6G network, which is published in 2025. In this presentation, I will explain the background of the study, the technical approach, my critical analysis, proposed improvement and its real-world relevance. Regarding this paper information, this paper was written by Ahmad M.L. Wakil and published in EuroSIP, Journal on Wireless Communication and Networking under Springer. It was published in 2025, making it recent and a relevant study. This research falls under AI-driven networking and next-generation wireless and 6G system. Regarding this paper information, this paper was written by Ahmad M.L. Wakil and published in EuroSIP, Journal on Wireless Communication and Networking under Springer. It was published in 2025, making it recent and a relevant study. This research falls under AI-driven networking and next-generation wireless and 6G system. Next, moving on to why I choose this paper. I choose this paper because it focuses on AI-driven networking, which is becoming increasingly important as we move towards 6G wireless network. Future networks are expected to support very high data rates, massive device connectivity, low latency, and intelligent automated decision making. Beamforming is one of the key technologies that enable this, especially in massive MIMO system. This paper is very interesting because it does not rely only on integrated artificial intelligence and software-defined networking to make beamforming more flexible and efficient. Alright, for the research problem in this paper, the main problem addressed in this paper is the limitation of traditional beamforming technique. In the existing system, which is a traditional beamforming technique, beamforming is usually hardware dependent. And it is very difficult to adapt quickly to the changing atmosphere and environments. And also, the existing system consumes significant power to work. However, 6G network require beamforming that is dynamic, energy efficient, and are able to adapt in real time. So, the main problem and the key research question is, how can beamforming in massive MIMO system be optimized to improve performance while reducing power consumption? So, moving on to the main contribution of this paper. Firstly, the paper proposed a virtualized beamforming framework, meaning beamforming is no longer fixed to physical hardware. Secondly, the framework integrates AI models and software-defined networking, which is SDN. The key achievements shown in the simulation results are about 19% improvement in spectral efficiency and about 22% reduction in power consumption. And last but not least, the paper provides a simulation-based performance evaluation to validate the proposed approach. Next, we will move to the technical approach, which is overall architecture. This slide shows the overall technical architecture of the proposed system. At the center of the SDN controller, which separate the control logic and the hardware. The AI module predicts channel condition, and it also optimizes beam direction dynamically. The virtual beamforming component is no longer tied to the physical hardware and can be easily reconfigured for different network scenarios. This architecture allows the network to be more flexible and adaptive. For technical approach in AI and networking methods, in terms of networking and AI method, the paper uses a machine learning model, specifically LSTM, and AI model helps in predicting channel condition, and it also supporting intelligence beamforming decision. Dynamic resource allocation is also applied, where beam direction are adjusted based on user mobility, interface, and network load. The performance is evaluated in a simulation environment and compared with traditional beamforming technique. Alright, For the critical analysis of this paper, we are going to move starting with the strengths. Firstly, the paper shows a strong integration of AI and SDN, which is highly suitable for the future 6G network. Secondly, the approach is well designed for dense 6G environment. Thirdly, the paper provide quantified improvement showing around 22% power savings and 90% spectral efficiency gains. And lastly, the paper is an open access and well documented, making it easy to understand and review. As you can see in this slide, these two figures is included in the paper, which is figure 2, 6G Virtualized Beamforming Optimization Framework, and also figure 3, step-based workflow of the proposed 6G Virtualized Beamforming Optimization Model, VDBOM. Despite its strengths, the paper also has some weaknesses. Firstly, the work is mostly simulation-based with no real network deployment. Secondly, there is no hardware or testbed implementation, which is limit real-time work validation. They only work based on simulation-based and not by practical tests. And thirdly, AI model can introduce high computational costs, which may be challenging in real-time system. And last but not least, the paper provide limited discussion on security, specifically concerning SDN and NVFV vulnerabilities. So, based on these weaknesses, several improvements can be proposed, which includes using lightweight AI model to reduce computational overhead, adding real-world testbed validation. Next is integrating zero trust security in SDN control plane. And next is applying energy-aware AI optimization technique. And lastly is exploring federated learning for multi-core environments. These enhancements will hopefully improve practically and security of the model. For the real-world relevance, this research has strong real-world relevance. For example, in smart city, it can provide better coverage and reduce interference. And in urban 6G network, it supports high density users more efficiently. And next, for IoT and autonomous system, it enables reliable and adaptive connectivity. And lastly, for network operators, performance can be improved without changing existing hardware. So, in conclusion, this paper presents an innovative AI-driven solution for 6G beamforming. The virtualization improve many things include flexibility, scalability, and also energy efficiency. Despite some limitation, this framework is future-ready and aligns with the real 6G deployment needs. Overall, this paper is strong and relevant contribution in network research. Thank you for watching my video, and if you want to have a better review on this paper, you can watch the link provided here. And it is very interesting paper, and I hope you guys will read it with me too. Thank you for watching. Bye.